All right, real quick. First thing I want to say is I'm only doing 4 lessons a week because I know you guys are going to have questions. And I'm also going to leave comments on your work. Like if you have problems wrong, I'm going to tell you to go back and fix them. So really, that's what day 5 is for. Obviously, you don't have to wait till Friday to ask me questions. You have questions, you can ask me instantly via email. Again, I really want people going onto this Google Doc, and I'll reshare it today. Today is Sunday. So I will reshare it on the Sunday, even though if you're doing lesson 4 right now, it's probably Thursday. But, you're doing 4 lessons a week. And then, again, I really like to see you get them, try to submit them, because then I'm going to leave comments. So you're going to have time to do other ones. And the beauty of this, guys, is we can all work at our own pace. Now, this does not mean, for some of you, that I'm working at my own pace, Mom and Dad. That means I don't want to do math today. No, okay? We still got to get things done, but it's okay if it takes you a little bit longer. So this first exercise is going to be your favorite, Alec. In the box below, sketch Cassandra's 5 rings. Oh yeah, time to make some rings. What up? Everyone take a moment to see my beautiful drawings. I know, I am the best artist in the whole class. That's not even a debate. If anybody has a debate, would you say something right now? I hear nothing. Nothing at all. So on B, it says draw a double number line diagram relating to the rings, relating to the number of rings as a percent of the whole rings. So this is pretty simple, right? Like, how many rings would be over here? 0. How many rings would be over here? 5. Now, is this a double number line? No, because it says for us, draw a double number line diagram relating the number of rings, which is the top one, as a percent of the whole set. So if obviously you had 0 rings, you'd have 0%. If you had the whole set, you'd have 100%. So we know this is broken up into 5 categories, and I'm going to do my best to break this up equally. Right? 0 rings, 1 ring, 2 rings, 3 rings, 4 rings. I want you to think about what percentage for each one would be. Now, no, I know, Gavin, what you're going to say. Well, I could have 2.5 rings, and that would give me 50%. Nobody wants a half ring, bud. All right? So, let's think about this. We're taking 100% and breaking it into 5 pieces. When you break 100 into 5 pieces, you have 20. So 1 would represent 20. And that means we're going to go up at a 20% rate. So 20 plus 20 is 40, 60, 80, 100. And what percent is represented by the whole collection? Well, the whole collection would be 100. What percent of the collection does each ring represent? Well, it'd be 20%. 2 rings would represent 40. 3 rings would represent 60. 4 rings, 80. 0 would be 0. I know, I got a little excited there. Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? I want you guys to think about this. All right, so as you thought about it, I think some of you might have overthought it. What does 1 ring give us as a percentage? 20%. What do we have? 100%. So, what will be the percent increase in the ring collection? Well, the increase will be 20%, right? That's what we're increasing because her aunt's only giving her 1 ring. If she gave her 3 rings, we would have a 60% increase, only a 20%. John increased his trading card collection. By the way, this is exercise 1. So he increased his trading card collection by 5 cards. He originally had 15. What is the percent increase? Use the equation, quantity, which is our part, equals percent times whole to arrive at your answer. And then justify your answer using a numeric or visual model. I want you guys to think about this for a second. All right, so again, don't be tricked. What is our whole here? It's 15 cards, right? What is our part? 5. So we have 5 equals, we don't know our percent and we know our whole, so 15x. So we divide 15 on both sides. And so what does this simplify out to be? Anyone? It simplifies out to be x equals 1/3. But is 1/3 a percentage? No. So we go in here and we do 1 divided by 3. Gives us our decimal. Okay? But now remember, this is repeating on forever, right? It's 0.3 repeating. A little too zoomed in there. My bad, guys. So x is going to equal as a decimal 0.3 repeating. So we times that by 100. And we know it's going to be 33 and 3 repeating percent. Okay? It's that 1/3. And we've all seen decimals like this. We've talked about it. You should have talked about it in 5th grade as well. Suppose instead of increasing the collection by 5 cards, John increased his 15 card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1? Why or why not? So let's go back and look at that. So when she increased hers by 1, it was 20%. Okay? So let's see. So we know that the part is going to be 1. And we know we have 15 in our whole times our percentage, which is x. We divide 15 on both sides. I'm sure right now, Gavin, you're shouting out the answer. And believe me, I sort of miss it. And then now Gavin's shouting out the answer. So when you do 1 divided by 15, you should get, I want to say it's 0.06. My calculator's telling me the wrong thing. So I'm going to go to my computer. Give me a second. So it gives me the decimal, x equals 0.06 repeating. Okay? And that means 6666666, like, yeah, right, I just did that one. But we times this by 100, and our percentage would be x equals 6 and 0.6 repeating percent. So is that the same as the 20% before? No. And the reason is how many cards does he have? 15. How many rings did she have? 5. Notice as our whole gets bigger, right? And we've talked about this with fractions, right? Our percentage works the same way, right? If I have a pizza that's split into 5 pieces, my one piece of pizza is bigger than Thomas's that was split into 20 pieces, right? Because each slice is going to be smaller. So here, right, that percentage is smaller because we have a greater whole than one before. All right, any questions on that? Please email me or sign up for a time. So, to give a little more background now, we're representing the change, right? We're adding in a baseball card. We're adding in a ring. So we're representing change, right? The change in our whole by a percent. And the reason using percent, and I ask you down here, based on your answer, how is displaying change as a percent useful? Well, it just showed right there, right? Adding 1 baseball card in this collection wasn't that big of a deal, right? It was a 6% change, almost 7. Where adding that 1 ring to her collection was a much bigger deal, right? And again, think about this, right? And this is a simple thing. If you have $100, is adding $1 into $100 that big of a deal? Maybe to some of you. Now, what if you had $1 billion? Would adding in $1 make that big of a difference to you? It wouldn't, right? You have $1 billion of them, right? It's just a small percentage of it. And that's why using percent as change is great. So there's the answer to C. And I really want you to think about that one, right? And this is something we have in our world, that we have billionaires out there that does $1 mean anything to them? No. it does to me and you. All right? So we look down at our discussion, and we might have to skip this, or I'm just going to discuss myself, but a sales representative is taking 10% off your bill as an apology for inconveniences, okay? And really this discussion is to think about, like, and we've talked about this, when you take a percentage off something, right? If I'm taking 10% off the $2 candy bar, I'm getting 20 cents off, right? Is 20 cents that much? No. If I'm buying a $50,000 car, I'm going to get $10,000 off. No, I'm sorry. $5,000 off. Sorry. Right? I'm getting $5,000 off. Now that's, I'm okay with that, right? Like, all right, I'm saving $5,000. Or if you're buying a house, a house at $150,000, you're getting $15,000 off. You're saving $15,000. That's a lot of money. So know that when you're getting something taken off, what's happening there? The larger the hole, more important. Right? The bigger your hole is, the more important. Where up here, the change wasn't as much, right? So when our percentage is the same, no matter what, it's the percentage is 10%, the bigger the hole, the better the change. Just a thought. So let's go to our example 2. Oh, stop shaking, Mr. Benoit. Whew. Ken said that he is going to reduce the number of calories that he eats during the day. Me and Ken are on the same boat. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. So Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by no more than 7%? Justify your answer. Well, I can tell you, I unfortunately probably eat more than 2,500 calories a day. So, good old Ken is doing pretty good. But we are comparing what? What was his old hole? 2,500. All right. So we have 2,500. And we're gonna leave our percentage as X. Because we know that, and actually I'm gonna go like this. I'm gonna use an inequality here. Because think about this, right? We know we want this to be less than 7%. Right? This needs to be less than 7%. Everyone with me? Everyone with me? Either way, we can keep it as equal sign. And know that this has to be 7 or lower, right? So I divide 2,500 on both sides, which would really be into like 22 divided by 25. And I go into my handy dandy calculator. And here's where we get confused. Okay. X equals 88. Which means our percentage, we move it over twice, that's 88%. Where are we going wrong? Okay, well, let's read this and see exactly what's going on. So, they didn't want him to reduce his number of calories by no more than 7%. Okay, so what is that 2,200? Well, 2,200 is 88% of the calories, right? It's 88% of what he eats. So when we think about this, right, this is, we're going to draw a little diagram here. Okay, so we know that 0 would be 0 calories, right? 0% would be 0 calories. We know 100% would be 2,500 calories. And we know now that at 2,200 calories, he's eating 88%. Okay? Is everyone with me on that? I hope so. All right. So, how much did he drop? Well, how far is it from 88 to 100? You guessed it, 12%. So how much did he drop? He dropped 12%. So did Ken reduce his calorie intake by no more than 7%? No, because he decreased it by how much? 12. And the way we could have done this differently is you could have said, okay, the new part is the drop is 300. So if we would have put 300 here instead, we would have gotten, when we divided 2,500 on both sides, we would have gotten 12%. This way still works, right? We just know that 88% is what he's eating. So what was the drop? 12%. Okay. So exercise 2. Skylar is answering the following math problem. Skylar, you come to the right guy. The value of an investment decreased by 10%, which is happening to a lot of the stocks right now. If you have any money in the stock market because of this coronavirus, the stock market has crashed big time. So the value of an investment decreased by 10%. The original amount of the investment was $75. What is the current value of the investment? So remember, when we think about this, draw my diagram. So 0% is $0. 100% would be, how much was the whole thing? $75. Okay, let's keep reading now. Skylar said 10% of $75 is $7.50. And since the investment decreased by that amount, you have to subtract $7.50 from $75 to arrive at the final answer of $67.50. Create one algebraic equation that can be used to arrive at the final answer of $67.50. Solve the equation to prove its results. Okay? Be prepared to explain your thought process to the class. Yeah, you be prepared, because when we come back next year, I'm going to make you explain it. Joking, trying to make funny. We look at this, right? It decreased by 10%, right? So what is it? It's 90%. And we got to figure what that is. So we know that, and this is the way you can do this, right? You could say your whole, which is 75, times your percentage, which is going to be a decimal, right? And so we could say it's 1 minus 10%, which is 1/10, okay, which would equal 9/10, right? This is a decimal, it's 9/10. Is everyone with me there? Equals our answer. So we know that 75 times 9/10, and if you put that in your calculator or if you solved it by hand, either way doesn't matter, you would get $67.50. So and the big thing about these problems, guys, is again, we're not putting in 10%. We know the change is 10%. So really, did he lose that much money? No. Now again, think about this, right? This is $75, right? What if this was $75,000? Okay. Now he would have $67,500. That means he lost about $7,500. Okay, a little bit of a difference. And that's where we were talking about over here, understanding when you lose 10%, depending on how much money you have invested, can really affect you. Turn to the next page. So Skylar wanted to show the proportional relationship between the dollar value of the original investment, X, as you can see in the chart, and its value after a 10% increase, Y. He creates a model. He creates a table of values shown. Does it model the relationship? Explain. Then provide a correct equation for the relationship Skylar wants to model. So again, I recommend scrolling back and just re-listening to me read that. All right, so I hope you reread that. So he wants to show the relationship between the dollar value of the original investment, which he does, right? Like that's $75, $100 investment, $200, $300, $400, right? Depending on your investment. So I want to show the proportional relationship between the dollar value of the original estimate and the value after its 10% increase. So my question for you is, we figured out, right, that after the 10% drop, it was $67.50, right? It's not $7.50. He's wrong. $7.50 is what you lost. What really is right, is $67.50, right? If you invested $100 and you would lose $10, so now your value would be $90, right? Because we didn't lose, we lost 10% of it. That means we lost $10 on a $100 investment. We still have $90. So he is wrong. I hope you understand that. Again, what I'm saying to you is all those numbers are correct for how much they're losing on their investment. Now, if you had a $400 investment, that doesn't mean when you lose 10% that your investment goes to $40, right? And let me put it in this way, right? If I have 400 pieces of candy and Thomas eats 10% of them, am I only going to have 40 left? No, Thomas is eating 40 of them. I'm going to have 360 left. Okay? Yeah, miss you, T. Rizzle. So, Justin earned 8 badges in Scouts as of the Scoutmaster's last report. Justin wants to complete 2 more badges so that he will have a total of 10 badges earned before the Scoutmaster's next report. If Justin completes the 2 additional badges, what will be the percent increase in badges? Think about it. I'm coming back. All right. So again, we're comparing 2 badges. If Justin completes the additional 2 badges, what will be the percent increase? So here we are. 0, 0. This is the percentage. 100% is 8 badges. With me? What would be 50%? Well, 50% of his badges are 4. What is here and here, right? We know it'd be 2 and 6. 25%, and 75%. So even there, we already have our answer, right? If you gain 2 badges, what's the increase? 25%. And we know this by taking our part, right, 2, and it equals our percentage. And I'm going to use P as percentage to start helping us, times our whole, 8P. We divide by 8 on both sides. And P equals 25 hundredths. We times that by 100 to turn it into a percentage. So P equals 25%. Okay? Express 10 badges as a percent of the 8 badges. So this one is a little different, and I want you to think about this. Express 10 badges as a percent of the 8 badges. So they're putting the 10 badges first, so that is our part. As a percent of 8 badges, that's our whole. So we know that 10, our part, equals our percentage times our whole. We divide that by 8. We divide that by 8. And P equals, if you put in a calculator, 1.25. Right? We would times that by 100 to turn it into a percentage, and it'd be 125%. And I want you to think about that, right? Like, he's added on to his whole number of badges. So now, obviously, he has more than his original whole. He has more than the original 100%. And again, we know the increase is 25%. So 100 plus 25 is 125. And so that's where it kind of comes into the next question, and I didn't even realize that. Does 100% plus your answer in part A equal your answer in part B? Why or why not? It absolutely does, right? Because again, we have our whole number 8, which is our whole. And then we know we have these 2 additional badges, which we figured out that 2 additional badges is a 25% increase. So 100%, the whole, plus 25% gives us 125%. Pretty awesome. It's now time to start talking about some kitties. The population of cats in a rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the kitties. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were were there originally. All right, back to our kitties. So, the population of cats, right? What do we know? Do we know the whole or do we know the part? Well, we know there's a decline by 30%, and we know that the current cat population is about to be 12. So is that what it was before? No, right? That's what it is now. So we know that, and I'll draw a little picture, that we're at 12, but we really don't know where that lands. Okay, we know we had a 30% drop. So we'll say this is 30% in here, right? This is 100%, this is 0%, this would be 0 cats, and we're trying to figure out how many there were before. So, what do we know? Well, and I actually put that in the wrong spot, my apologies. We know that there's 12 cats here, but what is this percentage? Well, we know there's a 30% drop, so this would be 70%. Okay? So now that we know this, we know that there's 12 cats at 70%. So we know that our part is 12. And that's going to equal 70%. What is 70% as a decimal? Well, we move it back to 7/10 times our whole, which we don't know, right? We're trying to figure that out. So how do we solve now, right? And this is that same equation we're using over and over again. Your part equals your percentage times your whole. And again, percentages are usually put in decimal form. 70% is 7/10. So I'm going to divide 7/10 on both sides. Now remember, we've talked about this, right? Like what happens when we divide by a number that is less than 1 but greater than 0? The number increases. So I sit here, I'm going to do my math problem. 12 divided by 7/10. Well, obviously it doesn't give us a whole answer, but it gives us approximately about 17.1. Now, when you're looking at percentages, are we going to have an exact percentage always? No. But they said roughly, right? Roughly 30%. I mean, that 0.1 cat, that could be kind of a weird cat. We could call him lucky for having 2 legs or something. Joking aside, right? Approximately how many cats? Well, approximately how many? There were 17 cats originally. So x equals 17. Again, pretty simple. You just need to figure out, okay, what do I know? Do I know my percentage? Yes. Do I know my whole? Do I know my part? Here, again, the picture really helped us. We know that there was a 30% drop from the 100%. So where were we? We were at 70%. So we knew that 70% equaled 12. And I just plugged it in and I solved for my whole, which was 17.1, which is approximately 17. Question on this, please email me. Or call. All your parents have my phone numbers. I know Gavin has been the only one to use it, but I am available by phone. I can't promise that kids will not be screaming in the background, but you guys know that. So example 5 says, I'm going to guess this is Lou. Lou, I know you spell yours differently, but Lou's math score on her achievement test in 7th grade was a 650. Her math teacher told her that her test level went up by 25% from her 6th grade test score level. What was Lou's test score level in 6th grade? All right, I want you guys to think about this for a second, so pause me. All right, back to the problem. So, my first question for you when we look at this is, before anything, did we have an increase or decrease here? Now, if you look at the topic, finding the original amount given a percent increase or decrease, the last one was a decrease, but this one's an increase, right? Her score level went up, okay? So we know we're going to have an increase, right? So we know that we have boop, 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 boop. We have 0% with 0. We know we have 100%, okay? So let's go through these and see what we know. So Lou's math score on her achievement test in 7th grade was a 650, okay? So 7th, 650. Her math teacher told her that her test level went up 25% from her 6th grade score. Okay, so we know that 100% is her 6th grade score. So I'm going to put an S for 6th grade. Okay, and then we went up 25%. Right? To get, I'm sorry, this is 25%. This is 125%, right? We went up to get her 7th grade score, which is a 650. So is everyone with me on that? So again, that S represents her 6th grade score. And we know that she went up 25%. So 100 plus 25 is 125. And her new score was 650. So they want to know what was her test score in 6th grade. So we think about this. Do we know the whole? Do we know the 100% the whole? No, that's what we're trying to find, right? 100%. S. We don't know it. Do we know the part with the percentage? Yeah. So the part is 650. So 650 equals, now 125%. As a decimal, we move it back 2 places, is 1 in 25 hundredths. So 1 in 25 hundredths times S. I know, my 5s and my S's, guys. I know. Thanks for the reminder. I appreciate it. So I divide by 1 in 25 hundredths on both sides. Now, looking at this, S is going to equal 650 divided by 1 in 25 hundredths. It's greater than 1, so the score is going to go down, right? Yes, Mr. Benoit. Yeah, so we know that it should go down, right? Because her 6th grade score was obviously less than her 7th grade score. So 650 divided by 1 in 25 hundredths gives me 520. And does that make sense? Well, we can check in a couple ways. Number one, it makes sense because it's less. But what is the change of 25%? How far is 650 from 520? Well, I know minus 100 is 550 and then minus 30. So the change is 130 per 25%. Let's see if that should go consistently here. So we have 50%, 25%. Look at those big fingers. My paws, my bare paws. I know I'm not funny. So if I minus 130 from this, I get 390, right? Because again, every 25%, I should have 130 change. Minus 130, at 50%, I should get 260. Now, what's 260 doubled? 520. Okay, we're still on the right track. Minus 130, we have 130. So does that make sense to us? Absolutely, right? It goes up by 130 every 25%.